Hi, my name's Alan Smith. I'm the owner of Alan Smith Pool Plastering out of Orange, California. Today we're at a pool that our company has just drained and getting ready to replaster. That is a perfect candidate for today's spot etching, Etching Deterioration. We're going to visit this pool and get inside and take a look at it. My career as plastering pools, which started in 1974, when we saw this phenomenon started, we called it freckles. We didn't have a good name for it, and then as research developed, we understood that it was actually an etching pattern that was coming on, and so it took on the name spot etching. As you can see in the picture, it takes on several different forms, from very small spots around aggregates, around the tile lines. But there's some important facts we need to know and understand exactly what this is and what's causing it. It's safe to say that there's a lot of different opinions on this, and we really need to know the facts. And that's what I'm here today to do, a presentation on that and to teach you and get you along this journey of trying to figure out what this spot etching is and what's causing it. Important facts we need to know is, first, what is pool plaster? We need to go through the basic principles and compounds of what pool plaster is, and it'll help you have that understanding and make your decisions on what this is going on with the spot etching. What are we seeing happen? Exactly what's these mechanisms that we see, how it's taken on an appearance. We're going to take a look at that too. And then what's causing this? Very important. We need to know the causation of this, and then that helps us come up to the next one. What are the solutions? The most important part of this talk, what can we do to help prevent this from happening? If you can't come up with a solution, all this is just a bunch of hot air. First off, what is pool plaster? Pool plaster, basically, when you see it going in on a pool, and it's either wheelbarrowed in or shot in under a plaster pump, it's troweled and spread and then slicked out and made smooth repeatedly by the craftsmanship of the pool finisher himself. And then after the final set, the pool's filled. As you can see in this picture here, these guys are troweling away at the pool, and underneath their feet something's happening. We have this microstructure developing and certain properties evolving that makes up pool plaster. Right now we're going to read this together and understand what's going on and what's evolving with this pool plaster product itself. It says hydration equals chemical change. Very, very important to understand. A typical swimming pool cementitious surface consists of a mixture of white hydraulic Portland cement, white sand, and that's typically a limestone carbonate like in most pool marble plaster jobs, or sometimes it's replaced with a white quartz silica, and water. There's 5 principal compounds that make up the cement paste when water and cement are combined. Very important. This is the 5 major components that make up all cement paste. I don't care if it's pool plaster, concrete, tile grout, precast coping. This is basically the DNA of all cements. Tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminoferrate, and calcium hydroxide. The first major compounds are all silicate materials, and the last one's a hydroxide, which is very, very important in understanding exactly what's going on. This is the big player. Of these principal compounds, calcium hydroxide, which makes up approximately 24 to 27% of the new compounds, is the most soluble. Very important to remember that word soluble, because that's what's going on here as we're going to find out. Calcium silicate hydrate, CSH, which makes up approximately 60% of the new compounds, is the densest and strongest. That calcium silicate are the other calcium compounds that we just read about. We'll lump those all together. When you mix all these ingredients together, you have the aggregates, the cement paste, and you also have little void spaces, little shrink cracks, and what we call an interfacial transition zone, or an ITZ. And that basically makes up the total cement matrix. The interfaces, the shrink cracks, and the transition zones are all part of the basic microstructure and properties of cements. Pool plaster takes on some very quick changes as soon as water's mixed into it, and as the troweling mechanism starts. And then over time, these compounds develop. Principally, what we want to talk about is calcium hydroxide, also known as, in the industry, is called Portlandite, because it is a derivative and an effect of when water comes in contact with Portland cement. It is the most soluble of all these compounds, and soluble means it can be dissolved at a certain rate. As we said, the calcium hydroxide, which is called Portlandite, is the most soluble. Now, solubility is measured a lot of times with the hardness of the mineral. In front of you see what's called the Mohs hardness level. It's a scale of rating the hardness values of each product that we just talked about. As you can see that the calcium hydroxide or Portlandite is a 3 on the total hardness of the Mohs hardness scale. The calcite or the marble aggregates next at a 9. And then as we get into the calcium silicate hydrates, those are up at 72 in total hardness, and the quartzite is 100. So there's different hardness levels to these different minerals. And what's that mean? What's that look like? Well, I'm going to show you a little experiment here. We're going to pour some pool acid on different of these minerals, and we're going to see how they react with acid, diluted acid, and it's giving you some idea of how hardness and solubility interact. Understanding the solubility of the different pool plaster components is very important. Calcium hydroxide being the most soluble of all the components in the plaster matrix, I want to show you a little example of what swimming pool chemicals, namely acid, will do to the different components. In these two cups, I have two different aggregates. One is the calcium carbonate, or the marble, and the other one is the quartzite aggregate. This one is a total hardness of a 9. This one's a total hardness of 100. And we're going to see what happens when we pour pool acid on there. So it gives you an idea of when things start to dissolve in a certain order. The softest, most soluble goes first, and then it takes a lot more aggressive water chemistry to dissolve something that's a lot harder. So for instance, we're going to put pool acid in some marble, and immediately it dissolves and reacts, instantly disintegrates. And this is diluted acid. This is 50% acid. I put it in the quartz, which is much harder, and it's non-reactive. It does not dissolve at all. So obviously it's important that we put the hardest, most least soluble components in pool plaster to ensure a long-term viable pool surface that will stand the test of time and hold up to the water chemistry in the environment that it's going to be in.